All right, this is the third attempt for Engineering 305, example problem 4.6. The problem that I'm having is with the audio. I think you guys have complained or said something a couple times, but this should be a lot better, but I got the headset on, so it is what it is. Example problem 4.6, we have an aluminum block that's shown in figure 419. It rests on a horizontal surface. It is heated up and has a 20-degree temperature increase. And so that is TF minus TI. So that's they're giving it to us as a delta T, but I think I like TF minus TI because that makes sure that we have our sign right and make sure that we get our strain right. They're telling us what our alpha is. It's 22.5 micro per C. That's our strain per unit of degree or temperature increase. And so when we get a 20-degree increase, what does our block do? Well, let's take one look at our block before we walk away from this. I'm going to enlarge our block here. You can see let me get rid of that. The dimension in the X, there's my X direction. My X direction, it is 100 millimeters. My Y is equal to 50 millimeters. And my Z is equal to 75 millimeters. Let's see, what am I missing? What am I missing? 20 degrees. I got alpha. That's pretty good. The problem is asking us to find my strain. Find my strain in the X, Y, and Z. It's also asking me to find my delta. That is the change in length in the X, Y, and Z. And it's asking me to find my shear strain in the X, Y plane. Why do you think they asked me for my shear strain in the XY but not in the YZ or the ZX? Why do you think that is? Well, the equations that we get to work with are those equations. The thermal strain is equal to alpha delta T, or we get the total strain equation, but we're not going to use that, so we're just sticking with what we've got there. So if we start working with that equation, we've got the strain in the X direction is equal to alpha delta T, which is equal to 22.5 micro per C times a 20-degree temperature increase. And with all that information, that's equal to 450 micro. My temperature's canceled, C and C canceled. I get 450 micro. How is that different in the Y direction? It's not. It's not different in the Y direction. So we're going to just keep plugging away. EX is equal to EY is equal to EZ. Ooh, it's easy. Okay, it's epsilon Z, but it looked like easy. And there's our answer. Sorry, green. There's our answer to part A. Part B. Part B. Let's find delta in the X direction. Well, how do we do that? In order to do that, I got to go back to my previous chapter. The strain in the X direction, the normal strain in the X direction, is equal to delta X over the length in X. So that's going to be, we're going to rewrite that, say delta, it's not an equals. It's not an equals. I'm not continuing that equation. I'm rearranging equation. Delta X is equal to the strain in X times the length of X. So that's equal to, the strain in X was 450 micro, and the length of X was 100 millimeters. And if I multiply that out, I get 450, and then I add the two zeros, and then I put a micro and I put a millimeter on there because I track my units as well. Well, that is a silly answer, honestly. That is a silly answer because I've got 45,000, and then this micro, which indicates 10 to the negative sixth or a millionth, and then I've got milli, which is 10 to the negative third. Let's go 45. We'll cross out those 3 zeros with a milli, and we get micrometers is my strain in the x direction. How's that? How's that? 45 micrometers. Now, strain in the y direction. Oh, I don't really want red. I wanted red for crossing that stuff out. Strain in the y direction. Let's try that all again. Deflection in the y direction is equal to, well, it was half the length, so it's going to be half the total deflection. And using the same technique, the strain in the z falls in between those, so it's actually going to be 33.75 micrometers. All right, there's answers. There's answers. All set. Last thing we had to do, what's the shear strain? Why did they only ask in the XY? Well, when this grows uniformly. It doesn't create any angular, it doesn't create any twisting, it doesn't have any shear anything. So that answer is 0. It was a trick question. You have to watch out for this book. They'll give you some of those once in a while. So be careful. I hope you're doing well. See you in class.